Let's talk hacking. It's a dirty job, but somebody's got to do it. Well, not really. Hacking into systems is illegal and harmful. But to fight the bad guys, we need to understand them. And to understand hackers, you got to understand their tools. One tool stands out: the C programming language. Remember the Stuxnet worm, that nasty piece of code messed up Iranian nuclear centrifuges? Guess what it was written in? You guessed it. CC is like the duct tape of programming languages. It's powerful, flexible, and gets the job done. Hackers love it because it gives them low-level access to computer systems. That means they can mess with your stuff real good. We're talking memory manipulation, system calls, the whole 9 yards. Plus, it's fast and efficient, which is what hackers need when they're trying to slip past your defenses. So if you're thinking about a career in cybersecurity, you gotta learn C. Trust me, knowing your way around C will make you a better defender. C wasn't built for hackers, but it sure became their playground. Back in the 70s at Bell Labs, a genius named Dennis Ritchie created C. He wanted a language to build operating systems. Back then, computers were like clunky old cars. C was like the wrench that let you tinker with the engine. C was designed to be close to the metal. It talks to the computer in a language it understands, binary code. This makes C super efficient. Programs written in C run fast and lean. Think of it like a high-performance engine. It gives hackers the speed they need to pull off their tricks. But C's power comes with a price. It can be dangerous. Imagine giving a chainsaw to a toddler. That's C in the wrong hands. It gives you a lot of control, but one wrong move and you can crash the whole system. And that's exactly what hackers exploit. Understanding its history and design is crucial to understanding the challenges we face in cybersecurity. C is like a Swiss Army knife for hackers. It comes with a bunch of tools that make their lives easier. Let's break down some of these tools. First up, pointers. These bad boys let hackers access and modify memory directly. Imagine having a map to a house and being able to rearrange the furniture just by looking at the map. That's pointers in a nutshell. Hackers use them to inject malicious code into running programs. Next, we got system calls. Think of these as direct lines to the operating system. C lets hackers make these calls and bypass security measures. It's like having a backdoor key to a bank vault. You can imagine the kind of trouble you can cause with that. And don't forget about C's libraries. These are pre-written chunks of code that hackers can plug and play. Need to crack a password? There's a library for that. Want to sniff network traffic? There's a library for that too. Understanding these tools is the first step in defending against them. Let's talk about memory. No, not your brain, but the computer's memory. It's where all the data is stored, and it's a hacker's playground when they're using C. Remember pointers? Those things that let you rearrange furniture just by looking at a map? Well, in the wrong hands, they can be used to mess with a computer's memory. Hackers can use pointers to overwrite critical data, change program behavior, and even crash the entire system. One way they do this is through something called a buffer overflow. Imagine a container that can only hold so much water. If you keep pouring, it's going to spill over, right? That's a buffer overflow. Hackers exploit poorly written code to overflow these buffers with malicious data, causing the system to behave erratically. And here's the scary part. These attacks can be difficult to detect. It's like planting a bomb that goes off later, after the hacker has disappeared without a trace. Section 5. Exploiting the System C's low-level access. One of the reasons hackers love C is its ability to get up close and personal with a computer's operating system. Think of it like having backstage passes to a concert. You get to see how everything works behind the scenes. C gives hackers that backstage pass. They can use it to interact directly with the operating system, bypassing security measures and gaining access to sensitive information. It's like knowing the secret handshake to get into an exclusive club. System calls are the key here. These calls are like instructions that tell the operating system what to do. Normally, these calls are tightly controlled, but with C, hackers can craft their own calls and slip them past the bouncer. Once they're in, they can do all sorts of nasty things. They can steal data, install malware, or even take control of the entire system. That's why understanding how C interacts with the operating system is crucial for cybersecurity. Section 6 case study when C code wreaked havoc. Remember the Morris worm? Back in 1988, this nasty piece of code brought the internet to its knees. Guess what it was written in? Yep, you guessed it, C. This worm exploited vulnerabilities in Unix systems, which were widely used at the time. It spread like wildfire, infecting thousands of computers and causing widespread disruption. It was a wake-up call for the cybersecurity world. The Morris worm showed how dangerous C could be in the wrong hands. It demonstrated the power of low-level access and the devastating impact of exploiting system vulnerabilities. The incident led to improvements in security practices and a greater awareness of the importance of cybersecurity. It also highlighted the need for secure coding practices and the importance of staying ahead of the curve when it comes to emerging threats. The Morris worm is a stark reminder that the code we write can have real-world consequences. Section 7, the ethical tightrope C's double-edged sword. C is like a double-edged sword. It can be used for good or evil. It's like fire. It can cook your food or burn down your house. It all depends on who's holding the match. On the one hand, C is a powerful tool for building amazing things. Operating systems, software applications, even life-saving medical devices, they all rely on C. But on the other hand, C's power can be used for malicious purposes. Hackers exploit its low-level access and efficiency to break into systems, steal data, and cause all sorts of havoc. So what's the solution? Should we ban C altogether? Of course not. Instead, we need to use C responsibly and be aware of its potential dangers. Just because you can do something doesn't mean you should. As programmers, we have a responsibility to use our powers for good and to write secure code that doesn't put others at risk. Section 8, the Code Guardians protecting against C exploits. So how do we protect ourselves from these C-wielding hackers? It's a team effort, folks. We need developers, security researchers, and everyday users working together. First off, developers need to step up their game. Writing secure code is like building a house with strong foundations. It's about thinking like a hacker, anticipating their moves and closing any potential loopholes. Security researchers are like the detectives of the cyber world. They're constantly on the lookout for new vulnerabilities and developing tools to detect and prevent attacks. And what about us, the everyday users? We're not off the hook. We need to be smart about our online behavior, keep our software updated, and be wary of suspicious links or emails. By working together, we can make the digital world a safer place, one line of code at a time. Section 9, Education and Awareness. The first line of defense. The best weapon against hacking? Knowledge. The more people understand about cybersecurity, the harder it is for hackers to succeed. We need to start young. Teach kids about online safety, just like we teach them about stranger danger. Show them how to create strong passwords, spot phishing scams, and protect their personal information. For adults, it's about staying informed. Read up on the latest threats, learn about basic security measures, and don't be afraid to ask for help if you need it. Businesses also have a crucial role to play. They need to invest in cybersecurity training for their employees, implement strong security policies, and stay up to date on the latest threats. Education and awareness are like the immune system of the digital world. Section 10, the future of cybersecurity, a cat and mouse game. The world of cybersecurity is constantly evolving. It's a game of cat and mouse between the good guys and the bad guys. As new technologies emerge, so do new threats. Hackers are always finding new ways to exploit vulnerabilities, and security professionals are constantly working to stay one step ahead. Artificial intelligence, or AI, is playing an increasingly important role in this battle. AI can be used to detect and prevent attacks in real time, analyze vast amounts of data for suspicious activity, and even predict future threats. But hackers are also using AI to their advantage. They're developing more sophisticated malware, automating attacks, and finding new ways to bypass traditional security measures. The future of cybersecurity is uncertain, but one thing is for sure, it's going to be a wild ride. We need to be prepared to adapt, innovate, and work together to stay ahead of the curve. Section 11, Conclusion C, a language of power and responsibility. C is a powerful language. It's the engine that drives much of the technology we rely on every day. But like any powerful tool, it can be used for good or evil. Hackers love C because it gives them low-level access, efficiency, and flexibility. They use it to exploit vulnerabilities, manipulate memory, and bypass security measures. But C is not the enemy. It's just a tool. The real problem is malicious intent. It's up to us, the users, developers, and security professionals, to use C responsibly and protect ourselves from those who would use it for harm. Let's work together to make sure that C, a language of power, is used for good, not evil.